we are starting our matrix unit. Woo! This unit is extremely short. It's so short that it literally only takes 8 days to learn. And so this unit, each day is a different part of the unit, and our test is actually next Thursday, and we're done with this unit. This is an extremely short unit. So again, don't fall behind, stay on top of your work, ask questions, and let's get it going. So this is 3-1, and this is gonna go on page 45. Okay, the first couple of slides you do not have in your notes, so just follow along. To add matrices A and B together, they must have the same dimensions. By dimensions, we mean the same row and number of columns. So row by column needs to be the same. And that's the same thing for subtracting, okay? So notice here, I have a 2 by 2 and I have a 2 by 2, right? They are the same dimensions, so therefore I can add and subtract them together. Capiche? All right. When you're adding and subtracting, it is element to element, meaning that it's in the same row and same column. Same row and same column. So if I'm adding A plus B, I'm adding element A and B that are in row 1 and column 1. I'm adding element A and B that are in row 1, column 2, which is why your due now had you going over element identification so that you understood what that meant, okay? See, it sounds easy enough? Okay, so what makes all this possible are the same properties that you learned in elementary school about adding 2 numbers together. It's the same thing for adding 2 matrices together. There's the closure property, and what the closure property means is that if you add matrix A and matrix B together, you're going to produce a matrix, okay? Commutative property, it does not matter the order you add your matrices. So think about 2 plus 3 is the same as 3 plus 2, agree? Order doesn't matter with addition. Associative property in addition allows you to add what you feel most comfortable with first. There is a unique property, your identity property, and the identity property is just saying if you have an identity matrix, your identity, so if you have a matrix that's made up of 0, 0, and you add it to any other matrix, it's going to produce itself, right? That's what that's telling you. And then you have the inverse property, and the inverse property is saying that if I add a matrix to its opposite, what does that equal? 0. Just like if I add a number to its opposite, what does that equal? 0, okay? So same properties that you have for a number, just a number, apply to matrices, okay? Please stop. All right, so this should start here. Part A, adding and subtracting matrices, okay? So in order to add together, the matrices must be the same. Each operation is completed by element, meaning the elements has to be in the same row and same column. Addition, order does not matter. However, subtraction, order matters, right? Order matters when you're subtracting. Okay, so our example 1 that we're going to do together, we're going to do it full out, but as you see the pattern, hopefully you will have less work and you can go on. But my job is to teach it full out, so here I am. We have matrix C plus matrix D, okay? So again, it's element to element. The corresponding element to 3 is 1, because they're both in row 1, column 1. Row 1, column 1, agree? So what I'm doing, I have 3 plus 1. Corresponding element to 2 is 4. So that's 2 plus 4. Corresponding element to 4 is 3. So that's 4 plus 3. Corresponding element to -1 is -2. Corresponding element to 4 is 2. And corresponding element to 0 is 4. Is there anyone who does not see why these are corresponding elements? Columns, when you go to a concert, rows you sit in, right? So you sit in the rows and columns hold things up. Okay, so when you simplify your matrix sum, 3 plus 1 is 4. 2 plus 4 is 4 plus 3 is 7. -1 plus -2 is 4 plus 2 is And 0 plus 4 is, so here is my sum. Okay. This was part 8, day 1. I don't. All right. Now, so that's addition. Subtraction. So subtraction depends on order, right? Order matters for subtraction. So here we have C minus D. So in the way that they're written, we're going from left to right. So from left to right, we have 3 minus 1, 2 minus 4, 4 minus 3, -1 minus -2, 4 minus 2, and 0 minus 4. Because they still are going to correspond to the same element, right? Different operation, but same correspondence. So when we simplify this, we end up with what? 3 minus 1, 2 minus 4, 4 minus 3, -1 minus -2, 1. A negative times a negative is a positive. So this is -1 plus 2, which is 1. 4 minus 2, and 0 minus 4, -4. So here's my difference. Okay, order matters. So instead of going from left to right with these two matrices, when I have D minus C, I'm going from right to left. Does it change the correspondence? No, just changes the way I'm going. So this time it's 1 minus 3, and then we continue. 4 minus 2, 3 minus 4, -2 minus -1, 2 minus 4, and 4 minus 0. So when we simplify, we have 1 minus 3 is -2, 4 minus 2 is 2, 3 minus 4 is -2 minus -1. It's a negative times a negative makes a positive, so it becomes -2 plus 1, which is -1. 2 minus 4 is -2, and 4 minus 0 is 4. And here's that difference. Okay, what do you notice the relationship between changing the order and subtraction? What happens to your differences? It's the opposite signs. The signs change. Those are the things that take place. That is why order matters with subtraction, right? All right, so I'm going to give you 90 seconds. All right, so these were able to be added and subtracted because they both were 3 by 2 matrices, right? All right, so for A plus B, when you're adding, you had -12 plus -3, which should give you -15. You had 24 plus 1, which is 25. You had -3 plus 2, which is -1. 5 plus -4, which is 1. -1 plus -1 is -2. And 10 plus 5 is 15. So that should have been your sum. On A minus B, so we're going from left to right. From left to right, we have -12 minus -3, which is -9. 24 minus 1, 23. -3 minus 2 is -5. 5 minus -4 is 9. -1 minus -1 is 0. And 10 minus 5 is 5. And this should have been your difference. Okay. If you have A minus B, how do you know what B minus A is? The signs are what changes. So instead of -9, you have +9. Instead of +23, you have -23. Instead of -5, you have +5. Instead of +9, you have -9. 0 has no change, and 5 becomes -5. And that should be your difference. How do we feel?
Not too bad. Wait, so
Doable? Awesome.
Are we gonna talk about when they're different? Like if it's 3 by 2 and
Then there's no solution.
no solution?
You cannot add or subtract if it's not.
Is there an infinite
No. All right, guys, so we're on to part B, solving matrix problems. So solving matrix problem. Here we have a team's, 4 teams win or loss schedule. And it says, it's looking for which team had the best record during the second half of the season. Okay, so it says that the second table shows the full season. So this is the total or full, right? And so therefore the first table shows us their first half of the season. And it wants to know which team had the best record during the second half. So, well, the full season equals your first plus your second, right? Does that make sense? The full season is the first half of your season plus the second half of your season. Are we confused with that? Okay, so we're given our full and our first. How do we solve for our second? We're gonna have to subtract. So second equals your full minus your first.
They don't do that.
Yes? If I'm looking for the second season, in order for me to see which team had the best record. Okay. Okay, so second equals full minus first. Well, my full right here are these elements. So this is my full. And my first half is right here. So to find my second, I'm doing full minus first. So we have 53 minus 30. Then we have 29 minus 11. We have 67 minus 29. We have 15 minus 12. We have 58 minus 25. We have 24 minus 16. We have 61 minus 24. And we have 21 minus 17. So to find the second half record, we're subtracting. Does that make sense? It's just like anything else. If you know the total and you know one value, to find the other value, you subtract. So we have 53 minus 30 gives us
23.
29 minus 11. 67 minus 29. 15 minus 12. 58 minus 25. 24 minus 16. 61 minus 24. And 21 minus 17. So here are their wins, their losses, and you have team 1, team 2, team 3, and team 4. And the question is, which team had the better record the second half? Which team had the better record? Team 2. All right, what are your questions about working a word problem with addition and subtraction matrix? Just your basic difference, sum, more than, total. All right, so your you do. So here, just how we talked about totals and knowing parts, here it tells us that we have A minus B equals C. And it wants to know what is, guys, what is A? So if we have A minus B equals C, and we know the value of B and C, what are we going to do to solve for A? We're going to have to add B, right? So go forth and find C plus B. Let me give you about 6. In order to find A, we have to do C plus B. So what does A equal? What do we get? We have 3.
6. -1.
All right, that concludes that piece. All right, let's take it up a notch. Questions, comments, concerns. All right, last part, part C. So 3.1 C. So 3.1 C is finding unknown variables, okay? And so when you're finding, guys, calm down. It literally is two-step solving. What is wrong with y'all? Oh my goodness. All right. So in order for two matrices to be equal to each other, every element and its corresponding element have to be the same, right? So if I'm missing an element, I'm going to use its corresponding element to find that missing element. So 9, oh look, it's the same. Oh look, oh no, these are, I don't know what this is. I need to solve for X. Oh no, what am I going to do? It says 3X plus 1 equals 16. Guys, how do I solve for X?
So what you want to do is
subtract 1.
Okay. So I subtract 1 from both sides. And what I do to one side, I do to the other. And now what do I do?
divide by 3.
Oh my gosh, it's a lot of work here.
It's 5.
So X equals 5.
Yeah.
I told you this. All right, now we're gonna do the next. So I'm making sure all elements are the same. Oh no, I get to row 2, column 1, and I have another mystery. Name talk. Mystery. What do?
Write it out.
I write it out and solve. We become Scooby-Doo and his friends. Okay. So
What happened to the
10 corresponds to
Oh,
the other element.
Oh, yeah, yeah.
So what do I need to do to get Y by itself, guys? I have to add 1. All this hard work. And then what do I need to do? Divide by 2. And so my answer is Y equals -2. Woo! That was a tough one there. I know. No, guys, I have to write it out because I'm teaching you your notes. But the hope is that you have, guys, the hope is that you have some type of skills already built in you that'll allow you to calculate this, okay? All right, so here's your you do.
All right. So -2 math, right? 1.
Wait a second.
Oh.
Here we go. So I'm in row 1, column 1 has to equal 9. Do we see that?
6.
So X plus 3 has to equal 9. So what is X?
6.
That's a weird 3.
Don't do all that. We don't know.
I'm doing it all just in case it was like, how did you get that? So X equals 6. We're good to go. They match up. Uh-oh. We got to do a little bit of math. So we have Y minus 1 equals 2Y plus 5. I'm going to subtract Y. It doesn't matter which way you do it. I'm going to subtract 5. It doesn't matter which way you do it. I moved my smallest coefficient first so that I don't end up with negatives. That's what I do. So you have -6 equals, and I end up with positive Y. What is Y? -6.
Oh, so I was right. Yes.
Just literally told you.
No, but I was right.
All right. If I already solved X once, do I really need to solve it again? No, but if you didn't believe yourself, you can try again. And what plus 1 equals 7? 6. It really was right. Yay. Okay, that concludes 3-1.